Welcome to this lecture series of Principle of Electrical Engineering. Today we are going to discuss a very important topic of electrical engineering, that is transformer. Transformer is a very special electrical machine which you can say is very much responsible for the expansion of AC transmission throughout different regions. In this course we will study single phase transformer. We will try to see the importance of transformer. Then we will look into the principle of operation of transformer. And after that we will see the constructional detail of a single phase transformer. Once you study the construction of a single phase transformer, we will then try to develop the equivalent circuit of a single phase transformer. And we will analyze the efficiency, voltage regulation, and try to calculate the losses in the transformer. So this is all we are going to discuss in this part of your course. So in this lecture we will start with the introduction of a transformer. As I told you that transformer is the most important component of any power system. In a power system we usually have three systems. First we have a generation system, then we have a transmission system, and then we have a distribution system. So throughout the power system, the transformer plays a very important role. Either if we talk about a generation system, then again transformer plays an important role. If we talk about a transmission system, then you will find that throughout the transmission line, we are forced to use different transformers. And if we talk about the distribution system, or you can say the consumer end system, so you will find that we use lots of different types of transformer. For example, in your locality you will find that you will use a three-phase transformer, that the rating of that transformer is bit lower if you compare it with the transformer that are used at the generation system. So you can say that a transformer is a very important component. You can say that transformer is a very important component of any power system. Okay. If we talk about the structure of a transformer, you will find that the transformer basically consists of two electric circuits that is linked by a common magnetic circuit. As you studied a magnetic circuit in the previous lecture, so we basically use core in order to establish a magnetic path for the flux. So in a transformer also we use different types of cores, and through that cores we link two electrical circuits which will then help the voltage and current levels to be changed, keeping the power invariant. So this is the beauty of a transformer. We can change the voltage and current level, keeping the power invariant. That is, the power will remain same, although you can change the voltage and current rating. So we can say that the transformer can change voltage and current, keeping the power invariant. And if we talk about the construction of a transformer, you will find that the two electrical circuits are linked together through a magnetic core, that is magnetic circuit. So this is the electrical circuit 1, this is electrical circuit 2. So you will find that there is no electrical connection between the two circuits. So you can say that transformer isolate two electrical circuits. So from this you can observe that the transformer can also be used to isolate two electrical circuits. Now another important thing about the transformer is that the change in voltage from one level to the other can take place without any change in the frequency of the voltage. For example, that is if the frequency of the voltage V1 is 50 Hertz, then the voltage you obtain at the secondary side of the transformer, that is at electrical circuit 2 V2, you will find that the frequency of that voltage is also 50 Hertz. So you can say that in a transformer, change in level of voltages takes place without changing the frequency of the voltage. That is, the frequency remains constant. Whatever the frequency we are having at the primary, you will obtain the same frequency at the secondary as well. So from this discussion, we came to know that transformer can change the voltage level as per the requirement. So it means that wherever we need to have a high voltage, we can use a transformer of high voltage rating. Wherever we need to use a low voltage, we can use a transformer of low voltage rating. So we can say that one could choose a moderate voltage for the generation of AC power, a high voltage for the transmission of the AC power over a transmission line, and at the consumer end where we need a low voltage, we can use a small or safe operating voltage transformer at the consumer end. Another important thing that you need to know about the transformer is that the transformer is an electrical device. Transformer, in a short form we write transformer like this: transformer is an electrical device which is static in nature. That is, there is no static machine, that is, there is no rotating part in the transformer. Because of the static nature of this electrical machine, the efficiency of the transformer is high. As you know that if we have a rotating part in the transformer or in any machine, then it means that there are some other losses associated with that rotating part. That is, we also have a frictional losses. Okay, so we also have a windage losses. Okay, so because of those losses, the efficiency of the machine reduces. Whereas in case of transformer is basically a static device. Therefore, the efficiency of the transformer is high, and it is as high as 99%. Typically, you will find that the transformer efficiency is more than 95%. So the efficiency of a transformer is high. That is, transformer is a very efficient electrical machine. Now we will try to understand the importance of the transformer, why this machine is so important, and why we cannot develop this power system without using a transformer. That is, what are the issues takes place if we didn't use a transformer. Okay, if we understand the issues takes place if we didn't use the transformer, then we can easily understand the importance of the transformer. So basically, if you look at the power system, you will find that we have a generating system, that is the generating stations, that are basically located at hundreds or more kilometers away from the load centers. Load centers are basically the distribution centers, or you can say that the consumer centers. Okay, that is for our case, you can say that the load is the load of our residential colony. Our residential colony is very much far away from the generating station. Okay, so usually this happens that the generating stations are very far away from the load center. Now what we have to do is, for transferring the power from the generating stations to the load center, we need to take that power through a long transmission line. So, for example, let us have a look on the picture. Let us suppose that this is the generating station. Okay, and this station is basically very far away from the load Let us suppose that this is the consumer load or distribution system. Okay, so if we want to transfer the generated power to the load or consumer end, we need to transfer that power through a long transmission line. The length of this transmission line can be hundreds or more kilometers, so it can be hundred or thousands of kilometers. Okay, so we need to transfer the power through a long distance. And so what is the issue with that? Why we are not able to transfer the power through this long transmission line? The issue is, you know that this transmission line obviously have some resistance. Due to that resistance, if the current start flowing through it, and the voltage start dropping across this line. For example, if the I current is flowing through it, then I into R1, that is the resistance of this line. So the voltage drop over here is V, that is generating voltage, minus I into R1. Again, if the current starts flowing onward, then you will find that again here further voltage drop, the drop is further I minus R2 and so on. It means that once the power reaches over here, you will find that the voltage drop is quite high, and which is not required. Also, you will find that there are lots of losses through the transmission line. So what we have to do is, it means that if we want the voltage level of certain value, then we have an option that we can increase the generation voltage. If we increase the generation voltage, then after the drop, maybe we will get a certain level of voltage at the load center. But the issue is, at the generation level, we cannot generate the voltage at a very high level, as the generator is a rotating machine and the level of voltage at which it generates power is limited, and it is limited to several kilovolts. Typically it is limited to 11 kilovolts. Now what other option we have? So if we want to transmit the power without any loss of power, what we have to do is, we have to transmit the large amount of power at this voltage level by means of large amount of current has to flow through the transmission line. So if we want to maintain the power level at the consumer end, so we need to transfer the power at a very high current. But the issue is that if we start flowing the power at a high current level, then what you require is, you require the cross-sectional area of the conductor of the transmission line should be large, because if the high current will flow through that and the cross-sectional area of the transmission line is not large, then the resistance of the transmission line is high, and due to that high resistance, the I square R losses will be more. That losses reduces the efficiency of the system. So flowing the power at a high current level results in flowing power at high current level results in the increase in the cross-sectional area of the transmission line conductor. That is, we need to use a conductor of high cross-sectional area, and if we use a conductor of a high cross-sectional area, then the cost involved in manufacturing that conductor rises to many folds. Not only that, the transmission line resistance is there high, so that resistance, this huge amount of current will cause a large amount of power loss. Because of this, cost of the transmission system increases. Obviously, we need to use more and more material to form the conductor, so the cost increases. So this is one of the reasons that we cannot go for a high current power flow. Another important reason is that if a high current will flow, if high current will flow, then what will happen? I square R losses in the transmission line increases. So this losses simply heat the transmission line, because it is a heat losses. Heat the transmission line and the energy will be wasted. So this results in the decrease in the efficiency of the system. So you can say that the efficiency of a transmission line become poor and the cost involved is high without the transformer. You can say that efficiency of the transmission becomes poor and cost involved is high without transformer. So that's why we can say that the transformer is very, very important part of the transmission system. So in order to address this problem of a high current, one option we already discussed is that we need to transmit the power at high voltage. But the issue is that the generator is not capable of generating the voltage at a very high level due to its practical limitations. And since, as you know, that at generating stations, lots of human beings working over there, so the chances of accident become high if a high voltage level is generated. So now we need to see there's another solution to address this problem of transmission line. So the another solution to this problem is to use an appropriate step-up transformer at the generating station to bring the transmission voltage level at the desired value. So another solution to the problem is, you can say that the solution to the transmission line power transfer issue is to use an appropriate step-up transformer at the generating station. So what will happen? At the generating station, we generate power at low voltage level so that there is no issue of crossing practical limit of the generating station, and also it is safe for the people working over there. So now what we have to do is, we will use a step-up transformer. We can represent the transformer like this. We will study later on. And we will, after generating station, we will step up the transformer, step up the voltage level using the transformer. And once we step up the voltage level, then we need a low amount of current to flow the power from generating end to the load end. That is the load end. This you can say load end. So since now the current is low and the voltage is high, the losses are also reduces. Current low means I square R losses decreases. Okay, so the efficiency of the system increases. Once we have the power over here, according to our requirement, we can again use a transformer and we can step down the voltage as per our requirement. So in this way we can use transformer in order to solve the issue of transmission line losses and the limitation of generating system. So let us have a look on the diagram shown in figure. This is a typical power system diagram simplified this diagram is in a simplified form. What we have is, we have a generating system over here and the voltage are generated at 11 kV. After that, since for transmission line we need to have a high voltage level. Why we need to have a high voltage? Because if the voltage is high, then the current will be low. Why the current is low? Because same amount of power we are trying to transfer, and the power is nothing but V into I. If the voltage is high, then the current will reduce. Okay, so if the current reduces, then the losses in the transmission line reduces. So we need to have a high voltage at the beginning of the transmission line. For that, what we will do is we will use a step up transformer. What a step up transformer will do, it will change the voltage level, that is from 11 kV to, for example, 400 kV. And at that high voltage level, the transmission takes place and the power transmitted to the load. At the load end, and since the load end is at lower voltage, so our requirement at the load end is a low voltage. So again we will use another transformer. That transformer again changes the voltage from one level to another, and this time this transformer will change the voltage from high level to the low level as per our requirement at the load end. So this is how transformer plays an important role in a transmission system. So because of that transformer, you will find that we can easily change the voltage level. We are able to reduce the transmission line current. Because of that reduction in the value of current, the power losses reduces. And also you will find that this transformer basically provide an isolation between a high voltage circuit and a low voltage circuit. Okay, so in this way, if there is a accident at one side of the transformer, then the protection at the other end can be provided. Now let us note some points. Usually a large size of transformer are located in places called substations. So basically at the generation system we have substations. In between the transmission line we can also have other substations. From that substation we will transfer power to different locations. So you can write that large size of transformer are located at substations. And if we talk about the cities or town, you must have noticed the transformer are installed on poles. These are called pole mounted distribution transformer. So if we talk about the transformer used in the distribution system means, you can say that in a simplified way, you can say that the distribution system is basically where the power get distributed, and these systems are basically, you can consider cities or town as a distribution system. In this system you will find that the transformer are mounted on the pole, and these types of transformer are called pole mounted transformer or pole mounted distribution transformer. This type of transformer basically changes the voltage level from 3-phase 6 kV to 3-phase 440 volt line to line voltage. So you can note that distribution transformer changes the voltage level from, there is 3-phase power with a voltage level of 6 kV to 3-phase power with a voltage level of 440 volt. This is line to line voltage. Okay, so this is all about the importance of a transformer. And from this you get a clear picture that how important the transformer is in any power system. Now we will try to see where the transformer lies in the hierarchy of the electrical machine. So if we classify the electrical machine, we can classify electrical machine into two main categories. One is AC machines and the other is DC machine. As name suggests, AC machine works on AC power, whereas DC machine works on DC power. Transformer is basically an AC machine because we need a varying nature of the voltage in order to induce the voltage in the other circuit. So if you look at the position of the transformer, you will find that transformer is an electrical machine, which is basically an AC machine. Okay, there are other AC machines like AC generator, AC motor. The AC generator and motor are basically rotating machines, whereas transformer is a static machine. So this is where the transformer lies in the hierarchy of electrical machine. Now in the next lecture we will try to understand the principle of operation of a transformer. Thanks for watching.